morning, everyone. Hope all of you are doing well. This is actually we had a keynote, so I'm the second talk. So thank you for joining me this morning for one of the first talks of your day. Hopefully it starts off well and continues to go that way. My name is Danielle Maxwell, and I am a junior distributed systems engineer at a company called Rotational Labs. Now, if you're wondering what does that mean, honestly, I just tell people that I'm a full stack engineer surrounded by people who are like, my colleagues are machine learning experts and data scientists. So I'm the person who is not a data scientist or machine learning expert, but I'm just surrounded by them. I dabble a bit like in a full stack, but mostly on the front end these days, but I will kind of like, work with Golang on the back end, but mostly just front end development. And so I mention that because, as I said, I'm not an expert, not a data scientist, not a machine learning expert. But the cool thing is that, with the AI hype, right, there's like, every time you turn around, there's like something new. You can create an AI application in so many different ways. But the cool thing that I've discovered is that there are also some pretty cool libraries, pretty cool tools in JavaScript that makes it pretty easy to kind of get started with getting familiar with machine learning. So, think of this as I'm not sure where everyone is on their journey, if any of you are like experienced with data science, or you may be just kind of like just interested just to kind of see what's out there. But if you're like me, you're a beginner, and I wanted to choose libraries that I think could actually help, like kind of like that stepping step, right? You kind of get a little more familiar with how to work with the machine learning model, and then you just kind of build on from there as you kind of learn more and more about exactly what's going on under the hood. So let's get started. I want to talk about, just briefly, the fact that the libraries that I'll discuss today, they can all be run in the browser, like the models that are used or created, they can be used in the browser. So you don't have to actually worry about having to like develop an API to be able to make a call to like the model to be able to display things on the front end. Cool thing about when you have your models in the browser is that it increases privacy for users because the model is on their device. And so, every time you turn around, right, there's like a new message, new email or piece of mail coming in your mailbox telling you that your data has been breached, right? I get something like, I feel like every other week from some company I've never heard of before. And so that's why it's really important to think about that, especially as we continue to see more and more AI applications get built. Another great thing about working with models in a browser is that it can reduce latency. And again, it's because the browser is already like on the user's device, so you're not making like additional calls to an API. And then also, because the model's on the device, you can actually work offline. So like if you were working with a progressive web app, this would be a pretty good use case if you had like a machine learning model that was in the browser. And then it can also make deployment much easier because, with the apps that I've created today, just the small demos, I've just deployed them as a regular static app. Nothing fancy, just kind of went to Vercel, said here, connect to my GitHub, and now I have a couple of apps that people can kind of go and, work with as a demo. However, it's not all like perfect, right? Because nothing is. And there are some trade-offs, things you have to think about. Although I did mention that latency is it reduces the latency when you have the model on a user's device. The model does have to be loaded initially, like has to be downloaded and actually loaded. So that can take a little bit of time, that first initial load. Also, a model could be like copied or extracted if it's in the browser. So that's something to think about. Like, if you create a model and then put it in the intent is for it to be used on device. There can be some performance issues if you're working with a really large language model. I would not recommend, think about like the number of parameters, how big a model is. So of course, the bigger, then the more users gonna have to download. So that's why this wouldn't be a great idea. So really large language models in the browser. And then just another thing that we always have to think about is like, how are you going to manage version control? How are you going to manage your updates if you're working with those type of models that are actually going to be on the device? Okay, so now I'll actually get into some of the libraries that I have been using on my own and learning more about. And the first is called Wink NLP. It's an open source natural language processing library, and it's developed by this group called Great Systems. They've also created, I think, like a statistical analysis tools as well, but I'll only focus on the Wink NLP library today. And I noticed that they are actually coming out with something else called Wink Composer, so something to definitely look out for. I think the intent is to make it like a framework. So the intent of Wink NLP was to make it easier to develop apps using natural language processing. They have pre-trained language models that can perform things such as like sentiment analysis, similarity detection, and it also works with multiple languages. So you don't only have to like work with English when you use this particular library. This one is one where like they already have a model, so you don't actually have to create the language model yourself. You can just work with it right out of the box. As you can see here, I have this kind of like screenshot that I took from their website to explain exactly what all is happening when your text is being processed. So with Wink NLP, you can, like, for example, the demo that I have, person can input text. The text is then tokenized. And from there, here's kind of how, like, where it says like its properties, it has like value, normal, case. So it's doing all of these like this different like processing, like lowercase, uppercase, stop words. It's looking for like type, suffixes, these different things. And then after that happens, once the text is tokenized, it kind of starts going through this processing pipeline. And here it talks a little bit more about exactly like those different types of like stages. So the tokenization, say you put in a paragraph. The paragraph could be tokenized as like words, could be tokenized as like sentences. So if you have a full paragraph, it could be like a sentence as a token, it could be by word as a token. And then from there, you have like sentence boundary detection. So the model is looking for like, where are the sentences? Like, where are they? It's doing a negation, so it's looking for these negative words. It's looking for sentiment, trying to get a feel for like, is this a positive? Is it positive? Is it negative? Is it neutral? Kind of makes you think about, what's that browser extension? I was just thinking about it, Grammarly. Not sure if any of you are familiar with that one, but if you have Grammarly installed and you start typing, it'll start showing you like, oh, this is like a happy zone, or this has a pretty neutral tone, kind of like, adjust as you continue to type your message. Here it also has like named entity recognitions, what NER stands for, so it's processing for that. So, when we're thinking about that, it's like a landmark. For example, we're at the Cobb Galleria, so that would be a landmark. Could be looking for like a person. So Beyonce, her name's on my mind because I was just listening to her on the way here. So that would be like a named entity recognition. You can have part of speech tagging, which as a former English teacher, I really thought that was pretty cool because I thought of apps that I probably could have used in the past. And then also you can do custom entity recognition as well with this particular library with Wink NLP. What that means is that, like, for example, they have it's called the Learn Custom Entities method. So there you could actually declare like your own custom entities. Great example would be like Atlanta is a city, but then you could have like Atlanta Braves could be team, or maybe you want to make it baseball team, baseball club if you want to make it more specific. And then here, just to kind of show a little bit more about like, what the tokenization is, I mentioned you can have sentences, entities, or tokens. You'll see here, well, hopefully you all can see it. I'm sorry if it's not really clear. But here at the top is showing like sentences. So it's like a paragraph that was entered as text. And as you can see, we have like it's been divided up into sentences inside this array. So here we have like 4 separate sentences. With entities, it's focusing on like the date, nearly 21 hours, or like a percentage. And then with just tokens, it's taking it just like word by word. So that's how it's being tokenized. So depending on exactly what you're trying to do, you can use either of these methods to be able to then kind of work with your particular app. Okay. So now, let me show a little bit of code. Make this a little bit bigger for everyone. Can everyone see this pretty well? Or do I need to make it bigger? How's that? Perfect. Okay. So one thing I want to note is that this is all done like in the browser. So when you work with Wink NLP in a browser, you do have to like bundle. You have to use a bundler. Since this is just a kind of like basic, straightforward demo, I just use Browserify to bundle the JavaScript to be able to actually display how this works. But here we're just going to call the model, and then also just get the Wink NLP package. Here it has, Wink NLP has these helpers that are called its and as. So, and I'll show a little bit more about like where the its helper is used. So here I'm just kind of grabbing like making for like documents for like submit button, the text I'm going to submit. And then when a user clicks the submit button, it's going to get the text, and then I am going to send that text to the model, and then it's going to tokenize the text that gets entered. And then from there, I'm going to just use like, I'm going to get the readability stats. This is something that is made available via this its helper. So I didn't have to do anything like specific to ask for this information like the Splish reading e-score, reading time, sentiment, word count, sentence count, or complex words count. So this information is all part of like the readability stats. And I'll show it like, I'll enter the text and then we'll show this information in the UI. And then just to add a little bit more, what I've done here is I want to actually highlight complex words in the UI. So if the text has any complex words, then I actually want to highlight it. And then we'll just display it in the browser. So let's see. Didn't actually save anything, so okay. So I am going to learn so much today at Connect.Tech. Let's see. There will be plenty of presentations about AI in JavaScript. Didn't come up with the most complex words here, but let's see what happens. Okay, so we highlighted presentations as a complex word. I'll be honest, I wouldn't have assumed immediately that that's considered a complex word, but according to the data set that was used to train this model, presentations would be considered a complex word. Here we've got this Splish reading e-score of 75, which makes sense because this isn't very difficult text to understand. So like the closer you are to 100, then that means the easier the text is to read. It just takes a few seconds to read, have the word count, sentence count, and that's everything that you need. You could use this particular library for like, again, if you were had like more complex text and you're looking to kind of like highlight specific words or parts of speech, anything like that, you can use it for like word clouds. Oh, I have a question.
How big was that model file?
How big? Ooh, that is a great question that I unfortunately don't know the answer to off the top of my head. But let's see. So we're using the English Light Web Model. That was going to tell me. Yeah, it's just going to take me to... Yeah, it's not very big. I just don't see exactly the exact size. Let's see, has it? Unfortunately, I'm not seeing it specifically here, but that was a great question. And I will, let's see, down here, it talks about speed and accuracy. 80, what's that? Okay, thank you. Oh, it's like you said it was 180, 1 MB, so 1 megabyte. 1 megabyte. Yes, it's pretty small. Yes, they have this English light model, and so it does quite a bit for considering how small the model is. Thank you for asking. It's a great question. Any other questions while we're talking about Wink NLP? Okay. Okay, perfect. So now I'm going to move on to Transformers.js. Not sure if any of you are familiar with this one, but it's also another open source library, and it was released by Hugging Face. With this one, you can run pre-trained models in the browser. So they've already been trained on a data set. You don't have to actually do anything special to actually be able to work with these models. As long as you just kind of choose what you want to do, and then from there, like if you want to do sentiment analysis, you would just choose a sentiment analysis model, and then you just be able to just put in a text, and it would just return, a score, for example. Another thing that can be done with Transformers.js is that you can convert models, and then use them in the browser, and you can use that with custom models as well. So what they tend to do with the Transformers.js library is that they have this Transformers library in Python, where a lot of models will get created, built with Python using like the PyTorch library. That tends to be the norm there. And so then those models will get converted to then be able to be used with JavaScript. However, if you happen to be working with a team, or if you happen to create your own model and it's not created and developed in JavaScript, you could load it up to the Hugging Face hub and then actually convert that one yourself. They actually have a particular script that you can use. Under the hood, they are using this library called the Onyx runtime to be able to convert those models, but then they've created their own script for their models that you can actually be able to convert them yourself. There are just some supported tasks, however, when you're using Transformers.js. So if you go, let's say you go into their hub, maybe you see, you happen to look at the Transformers library, which is actually the Python one. And if you see a model and you're like, oh, hey, this one isn't available in Transformers.js, but maybe I can convert it. You have to make sure that it's like one of these supported tasks, because if it's not, then it may not work. I know that in the documentation, it has been mentioned that they are looking to add more and more tasks and even add more models. But currently at this moment, you can only work with like natural language processing. So it's kind of what we saw with Wink NLP, the text classification and translation, computer vision. So you have like image classification and object detection, audio. So you can do like automatic speech recognition and then also audio classification, and then multimodal. So here an example would be like zero-shot image classification. So if a model is being trained on an image data set, what zero-shot just kind of means is that it should be able to, if it sees an image that it hasn't seen before, then it should be able to try to like detect what it is. So if you're training a model, let's say, I'll just say like on sports. So like this is a basketball, this is a soccer ball. But then maybe you just kind of show it something else that's not like related to what it's already seen. If you're working with this like multimodal type of a task, then the idea is that it should be able to try to like recognize exactly what the image is, though it hasn't seen it before. So an example of working with the Transformers.js library is that they have this pipeline API. And what it does is that it groups this pre-trained model that you decide to work with, and it groups these the inputs and the outputs. So it just processes all of that for you. An example here, the code you have, like you just import the pipeline, and then from Zenova Transformers, then you'll just kind of like actually say await pipeline. Here, I put in a task. So you have to put in a task. So here I said sentiment analysis. You can also then specify the model. In this particular example, it's just only the task. So what that means is that the Transformers.js library will just choose the default model for you if you don't specify the one that you want to use. And then here, I just kind of say, oh, having a great time at Connect.Tech. And then you'll get back a label, it's positive, and then a score, right? If you're working with sentiment analysis. An example that I created was with a image to text model. Let's make this much bigger. And my apologies for no longer having a dark mode. Spaces, this transformer spaces doesn't have, when I tried to switch it to dark mode, it didn't work, so. But this will be the only time I'm not in dark mode, so my apologies. But here, I am importing the pipeline, and I'm using a CDN here to be able to actually work with the Transformers.js library in this particular piece of code. And so in my UI, what will happen is that a user will click a button to upload an image, and then that'll just get sent to the model, and then the model will then create a text description of that image. So here, I just have to say that, telling Transformers.js is skip the local model check because this particular model will be downloaded from their hub. And here, I specified the task, so it's going to be image to text, but then here, I've actually specified the model that I want to work with here. And then let's get the image, going to turn it into a URL, and then from there, actually get the description, and then we're going to show it actually in the UI. And I'm using Transformers.js. What they have is something called spaces. So with these spaces, you can actually just upload your code, go back. It kind of looks very similar to GitHub, right? It looks like a repository. You can actually connect it to a GitHub repo, but when I created this, I just uploaded the code directly to their space. But here's how all of my basic files. And then if I click on app here, so here I'm just gonna click upload an image. Let's see. Going to on this one here. As you see, it's generating the caption. And 2 brown bears are playing in the grass. Yeah, not too bad. And they actually look kind of cute, even though they're bears. And then if I click another one, so totally different image. Here, this one is Marta, Brazilian player, soccer player that I'm a big fan of. And as you can see here, it says, a soccer player is kicking a soccer ball. So it's done a pretty good job. Actually once put another image in of another soccer player, but she didn't have the ball near her. She was just kind of celebrating. And so all it said was just a woman standing in the grass. And so I determined the more action you kind of see happening in the image, the better the description will be. Just to kind of show really briefly, kind of zoom out here. So, and also this is also part of the space. So I actually did not deploy this. Transformers.js just did all of this for me. Once I uploaded the code, they just made the UI available for me to view. But if I go back to, let's see, maybe community, yes. So if you go to community, you can click on models. And then if you click on libraries, and then if you select Transformers.js, you can see all of the all of the models that have already been converted specifically for Transformers.js. And you can choose a model. As you can see, they have a little over 1,200 at the moment. So it's a pretty well growing library, which I think is really cool. I will say that when you're working with these, as you can see, some models are way more popular than others. If I kind of go back to task, and I'll choose another image text to text. So this one only has maybe 280 downloads, whereas this one has almost 28,000. But if you click on the model, it actually give you more details about how to work with it. And you can even use click use this model, and it'll give you just some code just to show you how to get started with a particular model. I have noticed that sometimes though, some models in Transformers.js aren't as detailed as this one happens to be. So if you do happen to go into Transformers.js and you're like, hey, like how do I use this model? It's not giving me a lot of detail. Often they'll actually include like a link to the base model. And then those tend to have even more details. So you can like click on the base model and actually see, more detail about actually the model that's being used, even though that one will be more for Python. But it still gives you like the information that you'll need, I'd say. Okay, so now I'm going to talk about TensorFlow.js. TensorFlow.js can be very similar to Transformers.js in that you can work with pre-trained models in the browser. I will say that TensorFlow.js doesn't have as many, like in their hub, as Transformers.js does. So as I mentioned, I think it was like a little over 1,200, almost 1,250 models that you could work with Transformers.js that have already been converted. Whereas if you go to the hub for TensorFlow, from what I've seen, it's nowhere near as many. However, they do have like pre-trained models that you can work with, so you don't actually have to train it yourself. However, you can also use transfer learning with TensorFlow.js, which is not something that you seem to be able to do with the models in Transformers.js at the moment. So what that means is that you can actually take a model that has already been like created in TensorFlow.js, and then you can train it with your own data. And then another thing that you can do is actually you can create your own models. You can actually create your own neural network and then create your own model from scratch with your data set with TensorFlow.js. So, we kind of started off from the winking up here, like, okay, I'm just gonna like use this model. It's gonna do all of the work for me, but it only works with natural language processing. Transformers.js, Transformers.js.
Yeah, I just wanted to ask, is retraining the models like the same as what they call fine-tuning, or is that different?
So it can be like fine-tuning where you're taking the model, because you can have like, depending how you like work with the layers of the model, you can kind of like freeze and then just kind of like add your own data set to it to kind of like for it to learn on that as well. Great question. And I was gonna say, with Transformers.js, you saw we had more models available to us, right? It wasn't just natural language processing. We had image to text, had audio, still had the natural language processing, but it had so many more other options that we could work with in terms of the apps that we can develop. And so now with TensorFlow.js, we're taking even a bigger step, because now it's like, hey, you can actually work with your own data set. You don't have to work with a model and then that specific data set that it was trained on. You can fine tune or work with transfer learning, or you can even create your very own model from scratch. Something just to mention is that TensorFlow, the tensors, are basically just like multi-dimensional arrays. So, but they're all in like one uniform type. So you'll kind of, like in the code, you'll kind of see like, TF, like TensorFlow, but it's like tensors because it's working with 2D arrays. So like something I kind of like ran into sometimes, I would get this error that would be like, oh, it's looking for like a 2D, or it's looking for like the data in a certain way. And I was like, I have no idea what you mean. So it took me a minute to kind of understand what was happening because I was so new to it, right? Models, so the tasks that are already like kind of like created for TensorFlow.js: image classification, object detection, pose detection, and also speech command recognition. I created a demo app for another talk where I used an image classification model where it's kind of like uploaded an image, and then it would just kind of show kind of like a little box like, oh, this is a person, and then how confident the model is in like whether or not the person, like whether or not it's actually a person, like it was 50% confident that there was a box around a person, or maybe it was 93% that there was a box around a person. A particular model that I worked with for TensorFlow.js, it seems to only really like be trained on like a data set for people. So that would be like a really great use case to take that particular model and then train it with like, maybe if you want to create an app that recognizes certain food types or certain like trees. I was on a trip with my colleagues earlier this year and we were walking around and someone was like, oh, what's the name of that tree? no clue. But there was an app, and someone had already created an app. So I'm pretty sure they did the same thing. They just took a data set, taught it on different tree types, and then bam, you can just take your photo and like you know exactly what you're looking at. Okay, so now,
Do you have any plans for us to start creating the models and train them from scratch? Do you have any pointers where we can start creating the models and train them from scratch?
sure, yes, actually that's my next demo. Great question. I'm actually gonna show like, you know, how you can work with the model from scratch. And so what I'm gonna do is I'm actually gonna start with a bit of another library called Danielle.Js, just to really quickly show what you can do with like data analysis in JavaScript as well. Because, you know, if you're working with a model, you're gonna choose a data set, and then you may have to like clean that data set. You know, it's very popular, like you can do that in Python. There's a library called Pandas that's really popular to do that. And then Danielle.Js was essentially kind of like modeled after Pandas. It wanted to be kind of like the JavaScript Pandas. And so what I wanted to do was I wanted to create a model that could detect Twitter bots. I found a data set on Kaggle.com. And this particular data set, it had like, you know, tweets, had like location information, things like that. And then it kind of like was already labeled, thankfully, where it kind of determined whether or not the tweet was like created by a bot or if it was not created by a bot. If it had not been labeled, then I would have had to like try to find a pattern, right? To help myself determine like, was a tweet created by a bot or was it not created by a bot? But for this particular example, I kind of went with something a little more easier, pretty basic. So I am using observable for this notebook to use Danielle.Js. You can work with Danielle.Js in the browser. You can actually show all of this in the console. You can even kind of like, you know, like put it in the DOM and show it in the browser as well, no problem. However, I had like recently heard of observable, so I was like, hey, let me just check it out and see like how it works to use JavaScript in the notebook. Why not? So here I'm just actually just getting the library here, the Danielle.Js library. Because I'm using observable, I had to actually add in this function so that I can actually display the data frames or tables inside of this particular notebook. I'm really glad that someone figured this out before I had to figure it out, so it made my life significantly easier because I was like very confused, like why is this not working? So this display data frame function is just allowing me to be able to show the data frames in this observable notebook. However, if you are working with Danielle.Js outside of observable, you do not need this particular function. It's not necessary. So here I just kind of like uploaded the data set that I got from Kaggle. Just named it bot detection data. Here it's telling like read the CSV, and then I'm getting the data set. So as you can see here, I'm not going to show all of it because I think there's like 50,000 rows of data here. But just to kind of show, like you got the user ID, name, tweet, retweet count, mention count, follower count, like all these other details. So then here I just kind of said, hey, just show me the head. So this would just show me the first 5 rows in the data frame. If I wanted to use tail, it would just show me the last 5. So it gives me a way to just kind of, you know, see exactly what's in the data set, a feel for like, you know, what I'm working with. Then here is use this describe method. This particular method is actually like if a column has like, so here we have like retweet count, mention count, you know, have these like integers. So here it's kind of, you know, it's giving me a count, mean, standard deviation. You know, in some ways, like some of this data is not really helpful because like the mean of follower count, it's not really telling me a whole lot. But as you can see here, I got the count of 50,000. So that means like each row, so that like that's pretty good to go. But you can, you know, look at this different information. The bot label is 0 or 1 in this particular data set. So that's why you have kind of like this 0.5 because it can only be 0 or 1. There's no other value. And then something I wanted to do was just kind of say, hey, you know, check for any values that are NA. And so here's like, oh, it's false. Like here we've got like something in like all of these columns, right? And then notice like in hashtags, so like here we've probably got like an empty row here. It's probably just like because that person, that tweet didn't have any hashtags. Because with this data set, I'm not really working with hashtags, so I didn't really feel the need to do anything special, but I could have done like a fill NA. I could have filled this particular, any of the NA values with something, like I could have said none or like, empty something. Or I could even drop, you have the ability to drop NA values in columns as well. Okay, let's keep going. So then here, yes, I wanted to just get a data frame with this one here where I only wanted to see the rows where the bot label is 1. Because with this data set, if the bot label is 1, then that means that it's a bot. Like it was labeled as like a tweet created by a bot. Now, I don't know exactly how that was determined with this data set because unfortunately it wasn't specified. Some of the text you can kind of look at it and see like, animal sign, 6 data, good or. Yeah, that feels kind of probably like it didn't come from a human being, honestly. But I don't know exactly how they determined what was and wasn't created by a bot, or like if there was some other data set that determined this. However, if I were like really working with an application that I wanted to put into production, I would definitely want to know more about exactly how did they come up, like with those particular labels. Or I would even kind of like look for maybe my own data set with tweets and then kind of like work with like how do I want to label them myself. So here it's kind of I created like the bot. So getting this data frame, it's using this called like lock method. And then I'm just saying like get this row, bot label, and then where it equals 1, show that. Here I am just showing us a histogram where you have the retweet count. So here's like the count and then the values. So, number of times where the retweets were like, 500, 400. But it's pretty like, pretty high. Didn't really show me too much. And this here is for like the full data set. So not just for so like it's not just for only those who were detected as bots. So it could be human or hopefully human or bot generated. And then so here's just how I created the histogram. I just had to do like a layout, and then it's kind of like, this is specific to this observable notebook where I had to put like this code in braces, and then I also had to do the div like this to be able to show the plot in particular this way. But if you're working with Danielle.JS in the browser, you would just kind of like just write like you would normal JavaScript. You would have to do all of this extra. And then you could just kind of like put it in the browser by, getting your ID for a particular div. And I did the same thing here did a histogram of followers. So it's the exact same thing, the value, the count. It looks pretty much the same, not much really there. I then took here, I said, hey, I want to rename these columns. So where it says user ID, let's change it to ID. Where it says tweet, let's change it to input. And where it says bot label, let's change that to output. And the reason why I did that is because when I work with the neural network in TensorFlow.js, I wanted to just go ahead and have the name be input output so that, I could have the name, I could have just kept the name as maybe like retweet, or I could have just made it as like tweet and then, bot or whatever. But I wanted to make it input output, just make it a little more clear to me exactly what I'm working with in that, when I get to that code there. And then here I just printed the data frame that just kind of shows only the ID, the input, and then the output. Something that I did that Observable allowed me to do pretty easily was I was actually able to download as a CSV or JSON just by clicking a button. However, with Danielle.JS, you actually they have a method where you can say like, take a data frame that you've been working with and you can export it to JSON or to a CSV if you want to be able to use it outside of like your data cleaning and manipulation. Any questions before I now move on to the TensorFlow? Okay, so now here I have my just basic index.html, which didn't show for my other examples, but it's essentially the same where I've got like the script where here I'm just getting the TensorFlow model. Sorry, y'all, make this a little bit bigger for you. Made it maybe too big, sorry. But here I'm calling saying get the TensorFlow, the latest version of the package. And then also I am getting this universal sentence encoder model, and I'll explain why when I get to the JavaScript code, exactly like what that's doing. And then I'm just also getting my app.js. If I go back, just gonna get, so here what I did was I put the data just inside of this JavaScript file, just kind of make it a little bit easier for me to work with. However, I'm only working with like, I think like 61 rows because the full data set was 50,000. If I try to train a model of 50,000 rows of data, we would probably be here for a very long time, and I don't think we want to do that. So I just only stuck with 61, but put it here, and it's just like data.js. Didn't make any changes to it. Once I took that data frame, that last data frame that I showed, and exported it to JSON, I just kind of put it in here just to make things a little bit easier. And then now, okay, I'm gonna go to my app.js. So I am importing that data so that I can work with it here. And then I'm creating this train model function. So what I wanna do is initially actually load that universal sentence encoder model. And the reason why I'm doing that is because, okay, not too bad. So if I send like raw text, I am going to get a bunch of errors. Like I did that like when I first started working with TensorFlow.js. Like I tried working with just raw text, and I was like, why is this not working? The error messages weren't saying like, hey, you're sending raw text, that's not why it's working. But eventually, after a lot of searching, I discovered that that was the issue. And so so what I'm doing here is I'm getting the tweets from the data, and then I'm just gonna convert them into these like vectors, like numerical vectors. And the idea is that we're gonna take like, the words in the tweets, and we're gonna convert them into like a number. But then the idea is that this particular model is still gonna try to like capture the meaning, like the context of the text, right? Like it still needs to kind of know exactly like what the tweet is about. Because if it doesn't understand the meaning or the context, then it's not really gonna help us determine if it's a bot or if it's not created by a bot, if the tweet is created by a bot, not created by one. So after that, we've got like just getting those outputs, so the 0, 1. And again, 0 means that it's, not a bot. 1 means that it is a bot. So we're using here this one-hot method that, I'll be honest, I was like, what is that? But what it's doing here is converting these outputs. So like here I have example not bot, like 1-0, like in the array, and then the bot 0, 1. So basically that's making it so that the model can understand a bit more like the probability. So they can create a probability, a much better probability. Because even though the outputs are in the binary format of 0 and 1, having this like 1, 0, 0, 1 just makes it easier for it to understand like exactly like, all right, if it's a 0, then like the probability of it not being a bot is this versus like the probability of it being a bot, like when it looks at the tweet. So then we're just going to create the model. It's called a sequential method for TensorFlow. And then we have to add layers. So we are going to have things like three particular layers here. And basically what is happening is that we're saying, okay, here if I have like input shape, I'm going to explain this first to kind of go back to why I have the units this way. But the embeddings from that like model for that universal like encoder, so sentence encoder, so it's like a 512 dimensional. So that's why I have this input shape of 512, just because that's what the model does. So here we're saying like, hey, look at the 512, but then we're like, hey, maybe kind of like not look at the whole 512, like let's come back a little bit more. Let's try to like focus on like what maybe is more relevant. Let's try to like find some patterns without like, having the whole like tweet, right? This whole sentence. And then here we have this like activation function. And so what this is going to do is that it's going to allow this particular one, like a ReLU, like it's set. And what this particular function is going to do is it's going to allow the neural network to learn the patterns from like that text, like once it's like been, once you have that sentence, and then you do like the embeddings. So that's what this first layer is doing. Like it's taking the inputs and it's working with the inputs. Here, we added this dropout method. So what it's going to do is that it is going to drop, like as we're training, it's going to like drop nodes from the neural network. And the reason why we're going to do that is because I've learned that when you're working with the data set, like when you're working with training a model, something can happen called overfitting. And so when your model is being trained, like it can maybe like do a pretty good job of predicting the data that it's training on, right? So it could go in and say, hey, yeah, this is a bot, this is from a bot, this is not from a bot. But then if you give it like new data, then the probability may not be as great. It may not be doing as good of a job of detecting the differences between the bot versus the not bot created tweets, right? So that's why we have this dropout. And so that like as it's training, we're dropping those nodes just so that we can make sure that it's doing like a pretty good job of kind of still recognizing as it sees new data. Here we've got like another layer that we are going to that we've added here on the input. So we had like the 128. So now we've come down to 64. Still using the same thing here, the reloop. So we're using the same function here. But now we're like, so we went with 512, 128, 64. Like, hey, let's just kind of like, again, just kind of like bring it down just a little bit more. Like focus mainly just on like little bits here. And then we have another layers that's been added. And this is specifically for the output. So earlier kind of like created like a variable for the number of classes. So there are 2, so 0 and then 1. So that's the output label. So those are the number of classes. And then here we've got this particular different activation called softmax. And this one is basically converting the numbers into that probability, right? So I kind of show, I mentioned like if it's a bot, we have like that one hot, like 0, 1, 1, 0. So it's kind of showing that probability. So this softmax, this particular function is used because it's going to help us convert the numbers into a probability distribution. And then we're going to compile the method. Have an optimizer. It's just kind of like TensorFlow. They have like different optimizers that you can train on. I just went with Atom because it seemed like the basic one to go with. And then here we've got this categorical loss cross entropy. So what we're doing here is we're measuring the loss because we want to know how wrong a prediction is as the model is training. So that the model can kind of know like, oh man, like, if you take a test and if you get a C, you're like, man, like what did I do? How did I get a C? But then, if you go back and you get an A, maybe you want to compare, like what did I do to get a C versus the A? And if you got the A and then you got the C, it's like, man, like what did I forget? What did I like mess up? So, and then here we have this metric accuracy. I'll admit this metric here just came specifically from the TensorFlow documentation. It was just like a put in accuracy, and I was like, good to go. I'm not even going to question this even more. And so then we're training the model. So we have this model.fit method. So here we're like passing in like the embeddings. So one put like that one hot that was mentioned earlier. Then we have these epochs. I put 50. So you can make this like kind of any number. But this is a smaller data set, so I didn't really want to make it too high. I thought about making it lower, but I just kind of went back and forth and just made it 50. But this is basically the number of times that you'll iterate, like the model like kind of iterate over the training data. And then this batch size is the amount of data that'll be processed like at the same time. I made it 12. I made it 12 just to kind of make it a little more even since the number of rows, like the amount of data that's that's in this data set that I use just for this particular demo. Here we've got the validation split. So that's related to the amount of training data that's going to be used as a validation data. So you have to put it as a fraction between 0 and 1. So it's just 20%, just a little bit. And then here I have shuffle set to true. So basically it's just like before we kind of go and do another test, another iteration of the testing, we're just going to shuffle the data around because, we've all been students, like once you see something about 5 times, you kind of memorize the answer. And someone asks you like, why is it the answer? I have no clue, I've seen it 5 times. So that's why we're shuffling it around, right? Just to kind of make sure that the model is like not doing that. And then the model.fit has this like callback, has like different callback methods on like what to do like once the training ends. So here we're just saying like once the epoch ends, it's kind of like a log in the console. So error handling. And then we have our predict function. So here it's gonna like take in text, and then we're gonna create a prediction from that text that's been inserted. Or here, I'm just gonna do it all in the console because I haven't like downloaded the model and saved it and then made it available in the UI just yet. But that's what we'll do in the console. So here, we're gonna get the probability. So hey, what's the likelihood, like what is it if it's not a bot versus if it's a bot, like what's that prediction, what's that probability? And then we're saying like, hey, is it a bot, you know? So if the bot probability is higher than the not bot probability, then say, hey, it's a bot. And then if it's not, then say it's not a bot. And then we're just gonna show like inside the console, like it is a bot, show the confidence, the probability, and then just like, you know, message like this probability that it is a bot, probability that it's not a bot, error handling, and then we're just actually just gonna call like, hey, run this, just run like train model. And then here I just added in some test tweets from that particular data set. So like piece it middle must off enough great mind house machine. That really feels like a bot. Let's choose coach with community catch. Tree community work, leave, mini piece 8 fear, call now after answer serious kid, list late instead. Like honestly, these all kind of felt like bots to me. I don't know how you all feel, but I was like, I don't know. But anyway, so, and then we're just gonna kind of go through the tweets and then we're gonna log the result, prediction, the confidence, and the details. So, oh, sure.
So what if you wanted to predict multiple properties from the model? Like you want to predict if it's a bot and if they're verified. Would you need another layer for the verified property, or would you just do 2 outputs in 1 layer?
So what you could do is, yeah, you could have like, you can add a layer. Might want to even do like multiple models. So like create one that's like, is it a bot, is it not a bot? And then another one like, is it verified or is it not verified? You can do that as well. So it kind of really depends on like, and then also because of like the size of the data set, but this really depends on like exactly what you want to do. Okay, and then I'm going to run this really quickly. Go live. May have already started without me. Yep, sorry about me. Sorry, y'all. Let me make this bigger. So sorry. I cannot make this a little bit bigger, but I'm going to read what it's saying for those of you in the back. So it's just kind of like logging, saying like, you know, it's loading that universal sentence encoder, and then it's like encoding the tweets, and then started training the model. So then like each test, so I had like 50. So it's showing like, you know, 50, this was the loss value, and then this was the accuracy. So in the beginning, we kind of started off with like almost 44% accuracy, which is not great. But then on the next train, the next epoch, it went to like about 77%. And then went like to 80, almost 88%. And then it kept going until it got to like 90%. And then in the 90s, high 90s, and then it mostly kind of was at like 100% to like maybe like 97% for the accuracy of the model, which, I mean, hey, let's see if it's really that accurate, right? So here I have like, it's been analyzing those tweets that I put inside of that like function just to be able to predict whether or not those are human generated or like bot or not bot tweets. So the first one, the prediction was that it is a bot and the confidence was 99.32%. So the tweet was like, piece it middle money must off enough great mind house machine. And then it said it was a bot. But it turns out actually no, it was not a bot. I don't know what that person was talking about, but not a bot. The next tweet was let's choose coach with community catch. It said not a bot. And it said the confidence level was 99.93% that it was not a bot. which actually that was incorrect. It actually was a bot, right? So that tweet was generated by a bot. The next one, tree community work leave mini piece 8 fear. It said that probability of it being a bot is 99.38%, which actually was correct. And then for the last tweet, cold now, after answer, serious kid list late instead. The confidence level was 99.49% that it was not a bot, and it was actually correct. So it got two correct, 2 incorrect, which is, not too bad considering that it is a pretty small data set. And then like I said, I am not an expert at all. So that's how you can work with creating your own neural network and then developing your own model in TensorFlow with your own data set. Here, I just work with text because I thought it would be a little bit easier to kind of work with that, but you can do images as well, and then also audio as well. Any other questions? Because I see we're like at the end of time. And if anyone has any questions, I will be more than happy to kind of like hang around if you want to come up and ask any questions. But those are the JavaScript libraries that you can use. I have links, so those of you who already have the slides have the links here for everything for each library, along with the observable notebook, and also the repos for like Wink NLP, Transformers.js, and the bot detector. And then here is the QR code, again, if you would like to be able to look at the slides and the links as well. And that is it. Thank you so much for coming out. And like I said, hopefully kind of started off, because Gantz talks pretty good, so hopefully you started off pretty high, and it stays up that way for the rest of the conference. Thank you very much for coming.